Awesome. Okay. Well, it's Thursday, November 28th, and we are about to start webinar 5. For those of you that are new to these, welcome. For those of you that have been attending them, welcome back. For those that aren't familiar, what we usually do in these is kind of go over some of the latest developments in AI, talk about what's relevant to Grass and how it affects Grass as a protocol. And we briefly go over some of the latest updates for the protocol and what Grass is doing. And we usually finish it off with some Q&A from the community. So without further ado, let's start going through this slideshow. So this is a statistic that I've actually shown before. And it's a fun one, I guess. Every day there's 1 billion gigabytes of new information appearing on the internet. For those that aren't aware, it's Grass's mission to capture as much of those 1 billion gigabytes as possible. We're kind of in an arms race right now, where the only way for AI models to actually, have product market fit and proliferate properly, they need the ability to access as much net new information as possible. And this is something that Grass enables, and we'll get into that a little bit more, but not in too much detail because we've been repeating it quite a bit. This is another fun statistic actually that I found on the internet. Every second, 6 new websites are published. Anyway, I won't talk about that too much. I just thought it was kind of fun to share. So anyway, let's get started with some of the latest developments this week. Anthropic released MCP. Pixtral was released by the Mistral AI team in France. And Google's Gemini topped basically every LLM leaderboard, and no one seemed to notice, which is kind of interesting. So let's quickly talk about each of these 3 things. We'll get into one of them in a bit more detail, and then we're going to talk about what it means for Grass. So Model Context Protocol, that got released by Anthropic 3 days ago, I believe. And it's pretty surprising that they actually did something that's open source. It's really exciting. For those that aren't aware, they've basically been winning the LLM game, especially when it comes to purpose-built LLMs. Building probably the best coding models in the market at the moment. And it seems like they're constantly at the front of every trend. And it's really interesting because for the last few months, we were talking about, all of us at Grass, we've been talking about how AI companies, they need the ability to integrate outside data sources. And here's Anthropic, arguably the most important AI company in the world, developing an open source framework for integrating outside data to AI models. That'll be pretty exciting for LCR, mainly because it'll make LCR a lot easier to integrate. So anyway, huge, I guess, shout out to Anthropic, and I think we can all thank them for making tools like LCR easier to use. There's this one paper actually that I came across. It's not that new. It came out in the last month, and it's about knowledge graphs. And this has been a really exciting area of research. For those that aren't really following, I guess what people are coming out with in the AI research world. I'd say the most active area of research currently is multimodal AI. Another one has to do with benchmarking, and that's kind of a dying thing because people are quickly realizing that for probabilistic models like LLMs with billions of parameters, building benchmarks, it's a very unidimensional way of thinking about LLM performance, right? You have OpenAI that created a ChatGPT o1, which takes 20 seconds to think and give you an answer. And according to benchmarks, it's beating everything. But if you put it in a real world scenario, you can get the same result by hitting any other LLM 2 or 3 times and having it reason through the same thing. And that'll be done in a fraction of the time that 20-second thinking is. So it actually, we're starting to see that a lot of this LLM benchmarking research isn't really going anywhere. So a lot of it's focusing on multimodal, but the area that isn't really multimodal, or I guess not directly, that's still quite active is knowledge graph research. And that's pretty important actually for Grass, because for those that are familiar with this, knowledge graphs are a very crucial part of live context retrieval. which is what Grass's like end vision is, right? It's like the end goal of Grass. Now, this is a pretty cool graphic from that paper, and like it's the main reason why I'm sharing it. It's one of those standard things where they did a bunch of research. They used knowledge graph and yet again have shown us that they're the best way of retrieving data for LLMs. At this point, I don't think it's even an argument anymore. But I really enjoyed this graphic that they put together, so that's why I'm sharing it. And it's a pretty easy way of visualizing how knowledge graphs work, right? So like you have an LLM prompt, and in this case, it's asking about the relationship between like companies that are founded by these different founders. And then the knowledge graph, the way it works is it has all these different topics or like data objects, and then it has lines between them that describe their relationships, right? So you see here that, the blue lines are, the relationship between a company and its founder, and then like the red lines are business partnerships between different companies. So then with a knowledge graph, you can actually have a computer understand these relationships between different entities and different data points. And then when you connect that knowledge graph to an LLM, when the LLM receives a prompt, it'll understand the relationship between the words in that prompt, and it'll know what it needs to look for and where it needs to look. And that's been proven time and time again to beat traditional RAG search. So let's talk about LCR now in a bit more detail. Like, I don't think we've actually ever talked about the live context retrieval roadmap. So this is probably the first time we're ever making it somewhat public to the world. Now, this is a multi-year initiative, as many of you know. And along the way, like, as we go on this journey together, different parts of it are going to be released. Like I've alluded previously to, like within the next 6 months, a stripped down version of LCR is going to be put out. And I'm going to talk about that a little bit more soon. But I thought it might be instructive to talk a little bit about the different stages of LCR and what it's going to look like. So stage one is people in the, don't mean to interrupt this. I just saw in the chat, a lot of people are complaining about the sound. Is it just a few people or are others feeling the same way?
No, sounds good.
Sounds good? Okay.
Mm-hmm.
Cool. I have like this microphone here, which may or may not be useless. So let's see.
No, I think you're good.
Okay, cool. Anyway, yeah, so the crawling and indexing stage, how does that work? Well, from Grass's perspective, like the way it works is, actually, I think I have a slide for this. Yeah, there we go. Grass deploys millions of nodes all around the world. And what their job is to fetch different web pages from all over the internet. And then once a new page is discovered, Grass then processes it and then classifies it. So by using millions of nodes around the world, Grass is actually able to get around any types of things like IP rate limits, geoblocks, whatever. It can access basically the entire internet. It can do it very quickly and in parallel. And it's effectively building an indexing model that's actually never existed before. So that's actually really, really exciting. But as you can imagine, this crawling and indexing, this is the foundation of live context retrieval. And it's really important that we get it right. And in order to capture the entire internet, obviously like 3 million nodes on residential devices isn't enough. And that's why it's so important for everyone in the community to continue referring others to the Grass network and installing things like the desktop node, which is the best way to contribute to LCR and bring us to, even closer to a reality where LCR is being used by all the major AI labs in the world. Now, I throw a little statistic there at the bottom. As far as indexing goes, many of you are aware that not only does Grass do general purpose indexing, but also does very specific types of indexing. Now, the specific type of indexing I'm referring to here is multimodal data. I'll get into that in a second, like what that means and like what the implications are. But many of you are aware that I think at the last webinar we did, Grass had indexed 1.3 billion video URLs. And now we're at 2 billion as of this morning. So that's a really exciting milestone. It's a pretty significant percentage of the internet's video URLs. And at this point, Grass can look up like basically enough data to pre-train multiple multimodal AI models. So anyway, I just want to congratulate everyone here actually, because you're all a part of Grass, and this is a huge achievement for all of us. So what happens after the crawling and indexing section? This is something that we've spoken about a little bit, but not in a whole ton of detail before. So we figured we might as well get through it. The second stage is once you have this index of the entire web, the whole point of live context retrieval is to receive a prompt from an LLM, look up the answer on the internet, and give it back to the model in less than a second. And this allows any model in the world to have real-time. Someone's asking about recordings. We don't record any of these. These are for the community only. We don't share the slides. We don't publish anything. So yeah, thanks again for being here. But yeah, so the next step of this is building the frameworks for understanding LLM prompts. Now, the really interesting thing is the best way to understand LLM prompts is with other LLMs. So you can actually use another LLM to interpret the incoming prompt very quickly. And one of the cooler things that Grass is looking to do is actually deploy this at the edge. Now, obviously, there's certain types of edge computing that Grass is incapable of doing on just normal devices. And that's why Grass is working on other things. Huge hint towards hardware, by the way. Anyway, after that is the next step, which is ranking. Now, ranking is actually really interesting because that's where, from a semantic perspective, the Grass live context retrieval method changes very, very differently from traditional search. So most of you are aware that traditional search, it's not optimized for information. It's built to commoditize your curiosity. They make money off of your curiosity and your humanness, basically. So you'll search something, first few results are they're things that you're likely to click, but they're not necessarily the right answer. And that's due to things like SEO poisoning most of the time, and then sometimes other stuff, right? Paid advertising, whatever it might be. Now, with LCR, it's really important that this ranking step gets done properly. And then that's where cryptoeconomic incentives are so interesting, right? Because you can actually build a decentralized and unbiased model for making sure that all these rankings aren't being poisoned. They're actually optimizing for the right things. You can start, slashing router nodes or whatever if they're actually not following these steps. So that's pretty cool. After that, you have the knowledge graph. We've talked about knowledge graphs quite a bit. But the whole point of the knowledge graph is to kind of put all this together. So you have this internet scale web crawl. You have a way of interpreting the incoming prompt. It's the crawl is here, the prompt is here. And then you apply a ranking so you can make the crawl easier to access. And the knowledge graph is kind of what connects everything. After that's complete, the next step is going to be recursion and expansion. So that's, as LCR gets used more and more, it'll actually get better and better because it's going to train on itself. So it's going to learn even better how to interpret prompts, how to search the right things. And by self-teaching, it'll make the Grass index even better. And after that, the next step is proliferation. That's the stage at which every major LLM in the world that needs real-time information is tapping into Grass LCR and routing its request through your Grass node. Now, we've talked a little bit about the Grass strategic vision, right? The strategic vision, or the end game for Grass, is live context retrieval. That's the whole point of what we're building here together as a community. It's this massive network of millions and millions and millions of devices around the world that are routing these requests, scraping the web in real time, and retrieving it to make sure that AI models have the right information in real time, on time. Now, that being said, Grass is also engaging in a number of tactical initiatives. By tactical, I mean shorter term, and where results can happen a lot faster. The reason, and the tactical initiative that I'm talking about here, is multimodal AI. Now, there's a little chart here that explains what multimodal means. I understand it's kind of a niche term if you're not, sitting in the industry all day. So unimodal is your standard ChatGPT that came out 2 years ago, right? You send it text and it responds in text. And it's very straightforward, right? Like the way it works is you give it a question and then it is trained to find the next word in a sentence. And it just keeps doing that over and over and over again until the prompt ends. And if it goes on for too long, it starts to hallucinate. That's what they call, when the model diverges and starts making stuff up. Now, multimodal, the way that works is you don't only have to send it text. You can also send it voice. You can send it a picture. You can send it, a video. So in this example, it's sending a picture of a horse. It's saying, describe the picture. Or you can say, provide a picture of a horse, or write a song about the horse. Now, this AI model that is multimodal, it goes and decodes that prompt, and then it gives you a result. It'll give you, a picture of a horse, or it'll write a song about horses if you want it to. Now, the really interesting thing about multimodal AI is that 2 years ago, when ChatGPT launched, everyone was saying that by the end of 2024, multimodal AI would reach a point where it's dominating every industry. That hasn't happened yet. And that's been kind of a shock to a lot of people. But to us at Grass, it wasn't the biggest surprise ever. And the reason is multimodal AI is actually, the data is actually very scarce. And the reason that multimodal AI hasn't developed to a point yet where it's taking over every industry is because the data is just really, really difficult to retrieve. And in many cases, the only way to actually retrieve it properly is, well, if you're Google and you own Google Images and all these other things, or if you're a network of millions of nodes that are able to retrieve anything on the internet in real time. So this obviously created a very clear opportunity for Grass to go and start building some of the largest multimodal data sets of all time. And the Grass Video Index, which is 2 billion URLs, is actually being used currently by some major AI institutions to do some really, really cool things. And I can't wait for everyone to see those things, honestly. I couldn't be prouder of what Grass has been able to accomplish, especially in that area. And in terms of the multimodal content that Grass is scraping, just to give everyone kind of a way to visualize it, in one day, Grass scrapes a decade of content. So 6 million minutes of content. And the reason, when we say minutes, it's pretty clear that we're talking about video data. The reason video data is so valuable is because you can build all kinds of different types of multimodal AI models with video data. You need your model to go and understand words, in the form of text, and be able to translate that to audio, be able to translate that to videos, and be able to translate that to images. And funnily enough, the way a video file works is the video is just a bunch of images. So you have the video and you have the images. There is sound playing in the background, and usually there are captions. And if there aren't, you can run annotations, and you have all kinds of metadata and other things that you can scrape from the internet that are relating to it. Anyways, in terms of that type of data, which is some of the most valuable data today, especially for pre-training models, over a decade's worth is scraped every day by Grass. Another snapshot of the Grass dashboard. Anyone here that wants to watch this update, I guess, on a daily basis, you can just go to the Grass Foundation website. It updates at a random time of day, so maybe just refresh it whenever. But quite a few new stats will be added in the next week or two, I think including a time series. You can actually see how these things change day over day. So keep an eye out for that. Okay. And I'm keeping this webinar a bit short because I think for the next one, maybe we'll dive into things a bit more and make it a bit longer. We're keeping it a bit shorter just because for a lot of our community, it's a holiday today. And I want them to go back, I want to give you guys a chance to go and spend some time with your families. But I want to talk a little bit about what makes Grass what Grass is. Grass scrapes over 100 terabytes a day of data, and it uses over 3 million specialized residential nodes to do it. It actually runs on dedicated data center infrastructure that was designed by some of the brightest engineers on the planet. This is something that doesn't get enough credit actually at Grass. Is part of the core team's capabilities are absolutely incredible. Some of the things that we see happening, it's freaking insane. The latency problems that usually a lot of decentralized networks have. Grass doesn't have, because we have some of the top distributed engineers, like distributed network engineers in the world on the team. In terms of something like the data that gets scraped, there's a popular package for Python that gets used for scraping multimodal data. One of the engineers in the Grass team actually made a competing package that's 60 times faster that Grass uses in-house. That automatically just gives it this crazy competitive advantage. So massive shout out to the engineering team at Grass. Grass is building petabyte scale data repositories. There are only a few companies in the world that are capable of doing this, and Grass is a decentralized protocol that is doing it. Most of the time, you don't hear about decentralized protocols. You hear about this future potential vision of them disrupting an industry. Grass is doing it today. It's happening right now. Grass is building exclusive B2B partnerships and deals. And Grass, most importantly, has the Grass army. Everyone here, everyone in this Discord channel, everyone in the Telegram, everyone on X, Twitter, whatever, you all made this happen. So a huge thank you to you, and thank you for running your Grass node. Because by running a Grass node and joining the Grass army, you're helping make things like LCR a reality. You're making things like the Grass Video Index a reality today that major AI labs are using. Most important way to make sure that incentives are right. Now, there's one question, or I guess one phrase I've been seeing a lot, and I'm kind of, I think it makes sense for us as Grass to address it very, very briefly. How many people here have seen this floating around? A lot of people are talking about, hey, did you miss Grass? Don't fade the next Grass, because a lot of people are saying airdrop 1 was Grass, and don't fade the next one. Well, for those of you that are thinking this way, I have some news for you. Nobody missed Grass. Stage 2 just started. The next Grass is stage 2. And there's no second best. There will never be a second best. And once again, thank you so much for being here. Let's do some Q&A, guys.
There was a question regarding the data cleaning and pre-processing stage. So does Grass node and/or Grass desktop app contribute in any way here?
Yeah, the desktop node does. The extension doesn't. Actually, for those of you that are running the Grass extension and have not installed the desktop node, here's some alpha for you. Either switch to the desktop node or install the desktop node and run both of them if you want to keep the extension. This has things to do, without spilling too much information, this has something to do with airdrop 2 eligibility. So just putting that out there. It really depends on the data source and what type of data there is. If you're interested in some of the types of processing that happens with text data, you should check out Upvote Web on Hugging Face, the dataset card. It's 600 million rows of Reddit data that Grass open sourced the week after the OpenAI deal. If you go on there, you can actually see some of the processing that happens. A lot of it's pretty standard, right? You're cleaning off all the HTML objects and everything else that's not necessary to interpret language. And then some annotations get added. So things like GPT-2 tokenizer and being able to measure the how do I phrase this? Sorry, without using technical terms. Being able to evaluate how reliable text is. You can actually go and run a few packages over a bunch of text and say, okay, you can give it a language score. And if the language score is 1, that is probably pretty useful for a specific language for training an AI model. And if it's 0, it's probably just a bunch of emojis and not that useful. But then it might be useful for something like a signal for a hedge fund, for instance. Other types of processing that happen are mostly in the multimodal space. Now that's actually really interesting because multimodal data, the way Grass is doing it is by running a crawler and an indexer and like indexing these literally billions of URLs. And this is like the URL discovery process. And like once the URLs are discovered, all the metadata from the internet that's associated with those gets scraped as well. And we haven't deployed this yet, but it might be next week. We might deploy a few machine learning models over the Grass video index to make it searchable so that we can actually go and point the next step, which is like the Grass downloader, towards specific types of multimodal content. This is actually kind of this would be like a precursor to a future multimodal LCR type thing, which would be really, really cool. But yeah, I mean, it's like to answer the question about pre-processing, it really depends on the type of data. Some of the AI labs that we're working with, like what they like to do once they receive the data from Grass is actually run a bunch of LLMs over it to label it and annotate it. So yeah, it really depends.
Wow. Yeah, that was more. Yeah, go ahead.
Oh yeah, Sergeant Lazo asked where I got my hair cut. My wife cut my hair actually. So I'm sorry I can't share with the hairdresser. Sweet. Okay, I saw one other question. I might as well address it, and then we'll wrap it up. So the question had to do with Gigabud utility. So many of you are aware that Grass launched an NFT collection earlier this year called the Gigabuds. They're available on Magic Eden. And a lot of people have been asking, hey, what's the point of these NFTs? Like, what do they do? Or in like, I guess, crypto terms, what is the NFT utility for the Gigabuds? And I'm excited to announce, actually, that the Gigabuds have no utility, just Grass. So, with that being said,
thank you.
Let's wrap it up.
Okay. I think we can wrap.
All right. Thank you so much, everyone. Thanks again for joining.
Thanks, Andre. Thanks, everyone.